Welcome to epidemiology.
You know what I like a lot more than materialistic things? Knowledge. What is this?
It's a podcast. Hello everyone, and welcome to another episode of epidemiology, and especially warm welcome to any new listeners. This week's guest is Rachel Meager, an assistant professor of economics at the London School of Economics and Political Science, and something of a minor, dare I say major, celebrity of econ Twitter. She's also a fellow Aussie, so even if you don't appreciate the episode, your eardrums will doubtless revel in our Antipodean accents. Rachel is something of a Bayesian Bae, that's Thomas Bayes, the statistician, and our conversation is mostly about the associated dark art of conjuring facts from data, especially in economics. We talk a lot about causal inference, as almost all economists do these days, and why it's important, but also why it might be slowly suffocating the field. What other sorts of approaches to the generation of knowledge should we take in economics and social science more broadly? And what institutional reforms to economics might ensure that it stays fresh and relevant? Stay on the line to find out. Epidemiology. Hello everyone, welcome Rachel Meager to the show. Have I pronounced that correctly?
Yes, that is exactly right. It is confusing, but it is Meager. Yes.
What's the worst one that you've ever gotten?
No, usually people say Ma, but the worst one is Meager, which is understandable, but it's Meager. Yeah, it's a bastardized, attempted anglicization of an Irish name.
Okay.
As many Irish families did.
Yeah, amazing.
Yeah.
Well, it's a very special occasion. It's after Freedom Day, in scare quotes, in London. So we're actually coming to you live from the studio, being my couch. We've had a few beers, so we're going to tell you what we really think today. And what better way to start with our raw opinions than, Rachel, why don't you tell us a bit about your research?
Sure. So I work at the intersection of applied econometrics and development economics. So I'm really interested in how we can do more to understand both the causes of poverty on a global level, but also interventions that might be able to alleviate poverty at various different levels. And so that involves a lot of impact evaluation. And my work is really more about trying to see if we could do more with the data that we have on impact evaluations, both in the sense of trying to aggregate the evidence that we have in a sensible way to start looking at heterogeneity across settings, but also to start thinking about whether the type of statistics that we're routinely doing in economics are actually delivering the kind of understanding that we want to have of these contexts. And I think there's just a lot missing if we think about how economics research in development is used to make decisions or to make claims about the world, and what we actually do in our analysis. There's a lot of gaps. And I'm really just very interested in methodology, and those gaps are often methodological, and so I think that's just a lot of exciting work to do there in economics. Okay, sweet. So can you give us some example from your recent publications about the kind of work you do? Sure. So a really common thing that you would see in economics papers, from the most technical kind of seminar to, a newspaper article about a finding is you would say so we did this study, maybe it's a super rigorous study, it's a randomized trial, and, so we randomly gave half of these villages, say, access to microcredit, or half of these people, a financial literacy program, or some kind of education intervention, or something like that, and then we were able to track what happens to them, and we know that, whatever happens, most likely caused by this program that we put, because they're not selecting into it. And so we have whatever outcome we have. And then our conclusion is therefore this program has this effect on people. And so, we've gone from, a finding on a particular sample that is to some extent representative of a population of people, but we're just extrapolating in this wild way beyond any kind of sensible notion of a population that a statistical theory would actually support you extrapolating.
After evaluating millions of pieces of data in the blink of an eye, the Gambletron 2000 says the winner is Cincinnati by 200 points. Why, you worthless hunk of junk?
People want to do that, and I think it's reasonable to want to do that because the discipline of economics, or social science in general, is underpinned by this idea that, microcredit has some kind of core mechanism that is how it quote unquote works. So you want to extrapolate. But actually, the stats that we're doing are not designed for that kind of extrapolation. So I do a lot of work, and recent work that I've done actually is focused on microcredit, looking at different randomized trials of microcredit in different settings, and actually quantifying stuff as basic as like, what's the actual variation in the treatment effects of microcredit across different settings? It's not a trivial question because there's also sampling variation in the studies. So you need to decouple the sampling variation from the real variation. And that's just challenging to do statistically. And it turns out that in the case of microcredit, there's much less variation than there appears to be because there's a lot of sampling variation in these studies. So actually, like, microcredit pretty uniformly doesn't do all that much very exciting, unfortunately.
That's a bummer.
Like, there's some nuance on that, but like, you know, this is the kind of claim that people want to make about things like microcredit. Does it work? Does it not work? And, you know, you really have to start quantifying heterogeneity across contexts to even begin to grapple with that. And so, you know, just like even basic stuff like that is we're still working on in economics.
Yeah, right. Okay, cool. Very cool. Very cool. I really want to keep this conversation high level, but I also think that probably for some people we should probably explain what an RCT is and what like causal identification is, because we're going to be talking about it heaps. So I guess, can you give us a summary of what causal inference is about and why randomized control trials are like good for it?
Sure, totally. So this is like a big kind of revolution that happened in applied microeconomics. So, you know, when we think about studying, let's think about the Grameen Bank, right? So Muhammad Yunus started lending money to people, and, you know, then he said that the people that he lent money to had these really fantastic outcomes, and he attributed that to the fact that he lent them money. But of course, he didn't just randomly decide to lend people money. There's reasons, whether he's conscious of them or not, why he chose certain people or why certain people maybe approached him. So those sorts of problems are classically or technically referred to as selection bias problems, because the intervention that we're looking at is chosen by certain people, either the people receiving it or the people giving it out, to be given to certain groups and not others. And there may be systematic differences in those groups already that would cause different outcomes, even if there weren't this intervention. So a randomized controlled trial is a type of methodology where indeed you fully randomly assign some portion of a group of people who may be able to receive this intervention. You give it randomly to half of them or some portion of them, and then you track what happens to them. And you know that there's no other, in expectation, there's no other systematic difference between those two groups. And so that allows you to attribute, with some sort of technical caveats, broadly speaking, it allows you to attribute any change you see between these two groups to the intervention or the treatment that was given to them, because ex ante there is no systematic difference that we know of between the two groups.
Immigrants, I knew it was them. Even when it was the bears, I knew it was them.
Okay, very good. So and then I guess that brings us to our kind of big question for this episode, which is like, what do you see as the role of statistics in social science?
Yeah, it's really, I mean, I think that role is evolving. So, like, it, you know, I really see statistics as like the way that we construct knowledge in the social sciences, because we're trying to learn about the world and we're trying to learn about the data, you know, that comes out of the world, and interpreting that at all is a methodological question, and you need frameworks on that. So, I mean, at the moment, there's a lot of different ideas about what that should be and how that should be done. So I don't know that, like, my view of that is probably like kind of unusual.
Sure.
But like, I think, you know, statistics always has in mind like a question or a decision. So there's no like quote unquote objectively correct method to apply in any situation. And there's always costs and benefits of any statistical procedure you could design or imagine. And it's just a question of like, what is discerning for yourself as a social scientist, like what is the question I'm really interested in? That would determine what kind of stats I need to do. And, you know, we may need to develop new stats if we need to ask new questions, which I think we often do need to do, and that should be the role. Unfortunately, I think in many cases, the actual role of statistics in social science is like as a hurdle that people feel like they need to jump over to make like an idea that they already believe is true seem like quote unquote rigorous or improve it in some way. And I think that's like, unfortunately, the role that it does sometimes play as well.
So you said that we've got to think about what sort of question are we trying to answer and what kind of role can statistics play in that. So what's some of the questions in this spectrum? So like how can statistics manifest in different ways? Do you think?
Great, exactly. So like let's think about like a classic situation where you've got a bunch of like villages that received, let's say, microcredit, because that's something I just work on a lot. And then a bunch of villages, you know, and let's say this is in Ethiopia, because that's where one of the trials was done. And so, you know, what you really want to know is whether microcredit improves people's lives. Okay, so that's like impossible to measure. You know all about that. Like, how, you know, is life good? That's just, you know, there's just no economist that would dare to attempt to measure that. So, except for you. So
I'm mostly critical.
That's very, exactly. So that's very difficult, all right? But even if you narrow it down and you say, okay, all I care about is like business profits, right? So like people in these villages run businesses. Muhammad Yunus is saying that if we give them these loans, they can expand their businesses, they'll be more profitable. Fantastic. All right. So the classic statistical framework that you would bring to that, if you weren't thinking about what the question is, you would say, I'm supposed to measure the impact on business profits. Okay, so what I'll do is I'll compute the average in the two groups. So I'll look at the average profit in the group that got microcredit, that's the treatment group, and I'll look at the average profit in the control group, and I'll look at the difference. And then I'll say, well, that's the average treatment effect of microcredit, and that's the number that I care about. But actually, like, you know, if you just make one person in that set of treated villages mega wealthy, you will have a ginormous average treatment effect. That's probably not what you actually were hoping for. Right? If you make one person mega wealthy and everybody else stays the same, you massively increase the inequality in the villages, and you're not like raising everybody's living standard.
It's not development.
Exactly. So you're not like, when we actually think about development, we have a notion of like communities getting more resources, like groups of people doing better overall, not one multi-billionaire living in a village in Zambia, right? So if that's what you care about, you can't look at an average, right? Because an average doesn't distinguish between everybody getting X amount more and one multi-billionaire getting everybody's X. So there are statistical methods that allow you to look at that. So like some follow-up work that I did to my first microcredit paper was saying like, let's look at the way that the shape of the profit distribution changes when you introduce microcredit. So not just looking at the average, but looking at the entire shape. And actually we could see that there are small positive average effects of microcredit. They're very noisy. They're very small. But they are composed of a heterogeneous effect on the distribution where it's zero almost everywhere. And then in the tail, there's a noisy large positive effect. So it looks more like, to the extent that anything happens in microcredit, it's like some guy is getting kicked up into the tail of making a lot more profit. Maybe. It's hard to do inference there. Actually, it's not that dissimilar to what we think capital markets do in developed countries. Some person wins big. It's hard to do inference because those are rare events. But for most people, it doesn't benefit them. So if you think about the right question, it's very obvious you need to do something like this. You just say, okay, I actually was thinking about everybody kind of doing better. So I need to look at kind of the distribution of this group's outcomes, you know, not just the average. But if you just think about like, what was I taught to do in stats class, you're taught to compare differences in averages. But that doesn't correspond to the question you actually care about.
Oh, people can come up with statistics to prove anything can't. 40% of all people know that.
That also leads well into my next question, because you brought up stats class, which I guess alludes to kind of like what the basic skills are that we learn and that sort of thing. So when you first started talking about the role of statistics in social science, you said that this is sort of evolving. So where can you give us like a brief history of it? So where do you think it started? Where's it going? That sort of thing.
Well, it's hard. Okay, so it's hard for me to speak broadly to social science because I'm much more,
economics,
based in economics. Yeah. So even that, I think it's difficult. Like statistics itself has got such an interesting history, and it's so statistics and econometrics were kind of one discipline-ish until about 1950. So before 1950, there were both Bayesian and frequentist statisticians. And at that point, it was just very difficult to do Bayesian stats because you have to do a lot of math with these like distributions and like computing posterior distributions from, it's just very complicated to do if you don't have a computer.
I'm afraid we need to use math.
So at that time, the frequentist methods of Fisher, so the p-value, and Neyman and Pearson, so null hypothesis testing, were much more dominant because you don't need a computer to implement those things. They're very simple, and they're based on...
Still pretty arduous.
I mean, compared to Bayesian modeling, those are much more simple methods. And so those were sort of used, and then econometrics and stats kind of split off from each other around the kind of World War II, Cold War era.
Okay.
And at that point, actually, stats started to become somewhat more Bayesian. So, like, intelligence departments from that point onwards were using Bayesian statistics. Like, Alan Turing used, like, a proto-Bayesian computing methodology. But econometrics remained pretty frequentist and was focused on other questions.
Okay.
And so kind of what happened since then is that the computing revolution happened, and now there's like a big resurgence in Bayesian methodology in stats that hasn't really made its way over to econometrics. And so we are still, broadly speaking, in a mode where we're doing t-tests, looking at p-values, like comparing differences in means. And, that's sort of, of course, it's not all like that, but that's kind of broadly speaking where we're at. And there is, I think there's now quite a big gap between formal stats and then econometrics.
Right.
And then, of course, even an additional gap between like formal econometrics and what people actually do in practice. And so, there's just a lot of different, I don't know how to give like a good historical overview.
That's right. So what is the difference between Bayesianism and frequentism?
So it's tough. It's tough to kind of, and people have such different backgrounds in this. But no matter what I say, someone's going to get mad at me. Someone's going to be mad.
Actually.
But I think, like, broadly speaking, frequentist stats is based on conceiving of probability as a long-run frequency. And so when we get a given data sample from a population or whatever, we just get this data sample. The way that we quantify our uncertainty is we ask, like, a hypothetical question about if I were to get another random sample from this population, what would I see? What would I see, under different circumstances? So, if the world is really like this, if I did this repeated sampling, I would see, outcome A. If the world was really this other way, if I did repeated sampling, I would see outcome B. And it uses that kind of logic to sort of quantify uncertainty.
Okay. So like if I'm flipping a coin and it's an even coin, then I would expect it to come out 50-50.
Exactly.
If I flipped it 100 times, but if it's weighted, then I'd expect it to be 75% heads. Or
Perfect. Exactly. Right. No, that's excellent. That's exactly right. So Bayesian statistics, on the other hand, is much more focused on a more generalized notion of probability that doesn't necessarily rely on long-run frequency. So if you say, like, what's the probability it's going to rain today? Well, today only happens once.
Yeah.
So
or Donald Trump's election.
Yeah, exactly.
Yeah.
Right. So there's only one time, like, or 2 times or whatever.
Yeah.
That's not enough.
Yeah.
But yet we want to use probability to describe our uncertainty around events that only occur once.
Yeah.
And Bayesian statistics offers a way to, instead of saying, if the coin was a fair coin, then I would expect to see this type of data. If it's weighted positively, I expect to see this type of data. Instead, we would say, given the data that we have from the world that we're in, now what do we think the probability is that the coin was even?
Yeah.
Given what I see in the atmospheric readings today, now what do I think the probability is that the underlying fundamental is it's about to rain? As opposed to saying, like, well, on days that it rains, here's what the atmospheric readings looks like on days that it doesn't rain.
Okay.
So it's, instead of asking, given what the situation could be, what's the data that I could see? You say, given the data I did see, what could the situation be?
Okay.
So it's that reverse conditioning. So that's actually formally the correct object in some sense. Like, if you're trying to make inference about the world, you're making inference about this thing you don't see, conditional on the data which you do see by definition.
Yeah.
So in some sense, that's the correct object, the posterior probability, posterior being given after I see the data. The difficulty is that to compute that object, you can't just have the data. You also need prior probability. You need information outside the sample that you have about the relative likelihood of these states of the world. Because you know that the information you're getting now is occurring in a broader context.
Did you know that disco record sales were up 400% for the year ending 1976? If these trends continue,
that's kind of the methodological difference. But of course, if you were to ask, say, Michael Betancourt, who's a much more technical statistician than me, he would say a Bayesian is somebody that uses the language of probability to quantify uncertainty.
Okay.
Yeah. So formally speaking, frequentists don't do that because they never put, say, a probability on the coin being weighted or not.
Okay.
Yeah,
I see.
exactly.
Right.
They will, like, a p-value of the coin being weighted is the probability of seeing the data or a more extreme draw of the data, given that the coin is or isn't weighted.
Yeah.
It's not the probability that the coin is or isn't weighted.
Yeah.
That's a Bayesian object, but you need this other extra sample information that makes it's more complicated. It's a richer kind of space. It's a bit more difficult to execute.
Okay, that's interesting because, so you mentioned p-values a lot, and obviously we use heaps of p-values in science, but it seems to me like Bayesianism conforms more to, like, Popperian scientific method, and certainly to this notion that you, like, start with a theory, and you're kind of like, well, what I expect to see is blah. That's your prior. And then you take that to your empirical tests and then see what comes out. And on the basis of that, you update your prior.
That's right. Yeah, that's right. But actually, I feel like as an economist, we never get much of a crash course in history of science and stuff like that. So if you could offer, like, both your listeners and me, like, a very brief reminder, because this is something you hear about, but it's like if you asked me to define, like, Popperian kind of notion of science, I would not be able to give you a succinct answer. So if you could give me one, that would be awesome.
Yeah, well, so based on my, like, limited undergraduate learning of these things,
hell yeah. Hell yes.
So Popper, as I understand it, is motivated principally by the problem of induction, which comes to us from Hume. So it's this idea that if you observe a phenomena over and over again, you don't know whether that's certain to happen again or whether you just haven't observed enough of the sample. So the classic example is white swans and black swans.
Yeah.
So Europeans for centuries only ever saw white swans.
Right.
So on the basis of, like, your Bayesian inferences, you'd be like, well, I expect swans to be white. There's another swan. It's white.
Yeah.
And so you're really expecting all swans to be white. But it turns out that you just haven't witnessed enough of your empirical samples. So when you travel to Australia, you come across a black swan and your mind is blown, and you have to update your whole theory about swans. And so Popper's argument, or the problem of induction, is that essentially we can never get at objective truth. So you can start in a mathematical space and posit axioms and then derive proofs on the basis of those axioms. But what you've done there is derived proofs about an abstract mathematical space. So in order to bring that into reality, you're going to need to test that against some empirical data. Alternatively, you can base your axioms on empirical data, but then you're already in the realm of empirics. So you're already in a statistical realm and a probabilistic realm. So you have to solve this problem of induction in order to think about, like, how do we generate knowledge? And so Popper's kind of solution to this, because in a sense he like sidesteps it, is to say, well, we shouldn't think about confirming things, because you can't do that. There's always a possibility that... so the other classic example in philosophy is grue. So grue is a color that is green, or an object is grue, and that's its color. And it is green until a certain point in time, at which point it will become blue. Yeah, and so it's similar to the swans. Like, you never know whether just you're not up to that point in time. So this is in abstract conceptual thinking, you can never sort of get away from this problem of induction. And so Popper says, well, what we should do instead is falsification. So, and we shouldn't think about truth, we should think about facts. So if I keep seeing swans and they're always white, then I can, on the basis of these rigorous tests, like I've really subjected the phenomenon that I'm interested in to like controlled experiments where I've gotten rid of all the variation and I've like really pulled this lever and I know exactly what effect that had. And every time the same thing happens. And now I'm pretty confident on the basis of these rigorous tests, and ideally multiple tests of different varieties, that we understand this phenomenon. Then I can treat it as a fact. Not a truth.
Facts are meaningless. You can use facts to prove anything that's even remotely true.
And then you're still in this kind of Bayesian thing where possibly down the road, new things will come to light, and all of a sudden you'll have to dispense with what you thought before. And I guess the classic case study of that is the quantum revolution in physics. So Newtonian physics was a real poster child for controlled experiments. We identified these fundamental forces and whatever, and we seemed to be able to predict the motions of planets with a lot of precision, and it was all going really well. And then Einstein came along and the others came along and were like, actually, there's a whole bunch of weird shit going on that we can't explain. And now you realize that your theory just is missing bits. And so it no longer has the explanatory power that it had before, and now you need to update it.
Okay, so I think this is really interesting. So I would say, like, there is like an interesting inroad into the Bayes frequentist issue here, and that has to do, and I only know about this as like a statistical issue, that has to do with like events that you've never seen. So to some extent, this is a case where the more crucial input is like what we call the model space. So like, you know, like if you're saying ex ante, like what color are swans? Or like what color, like what's the probability that a swan is white? So, you know, it matters what the model is. So like, do you have a model that allows swans to be anything other than white? So since you're asking the question, what's the probability that a swan is white? Let's agree there should be a model where it could be non-white. So let's say like, okay, there's another option. It's either white or it's not white. Okay, so those are the two options. So if you are a Bayesian, you need to have a prior probability before you see any swans, or whether they're white or non-white. And so you could say, like, I mean, people were asking all the time, and this is the issue, like, what should the prior be? No one knows, but like what we do know, in any generic case, we don't know what it should be, but we do know that there shouldn't be a zero prior probability of any option in the model space. So there should be a non-zero chance. You're not allowed to have what's called a dogmatic prior that puts all of the probability mass on one option. So formally speaking, like all the theorems about Bayesian inference converging to the truth work as long as the prior is not dogmatic. So the prior needs to cover the model space. So if we're asking the question, what's the probability that swans are white? You need to have some probability that there's some non-white swans in the prior.
Yeah, sure.
In order for that to work as a model. So let's suppose that it's been 200 years and we're in Europe and we've only ever seen white swans. So a Bayesian probability that swans are white is going to be very close to 1, but it won't be 1.
Yeah, sure.
Because you had this prior probability sitting on, no, there's some non-white swans. And that will be degrading over time as you see more and more white swans, but it won't be going to 0. It won't be 0. On the other hand, the frequentist estimator of the probability that swans are white is 1.
Yeah. Because
it's the frequency of white swans as over the total swans, which is 100%.
Yeah.
So this is one nice thing about Bayesian inference, which is that like if you have a model that corresponds to asking the question, what's the probability swans are white? You have to have probability measure on the possibility that there's some non-white swans, even if you've never seen them. So you will not go to that edge and say 100. I'm sure there's no white swans,
right?
Because of how the kind of framework of the model is set up. But the naive frequentist estimator is just it's 100%.
Okay.
Yeah.
Cool.
Yeah.
Right. And so you said that you think over the last say 50 years or so, especially, there's been a growing kind of return of the Bayesian way of thinking to social science, in part driven by computational power.
Yeah.
Which I think is generally brought statistics into social science with an growing intensity.
Yeah.
I was also thinking about, in terms of the history of statistics in social science, just the way it's applied. So we're going to talk a lot about causal inference in this podcast. It does seem to me like the intensity of causal inference in research at the moment is kind of unprecedented. That if you take the clock back 20 years ago, maybe people were still claiming causation. They were still talking about their results as though they had causation. But actually the methods that we were applying were not causal methods. So do you see any kind of historical currents in how that's changed, at least in economics?
Yeah, I think for sure. So I think like in economics before like the 80s, I think there was a lot of, it was more like sort of model-based inference. So we'd have like a model of how we think the economy works, and then we would like try to match some moments to it, or like fit it to some data from the macroeconomy or from, the factory you were studying or whatever.
We studied traffic patterns and found that drivers move the fastest through yellow lights. So now we just have the red and yellow lights. Yay. Come on, stay yellow, stay yellow!
And that was kind of interesting, and there was this desire to get to something similar to an experiment, like what Fisher, was doing with agricultural plots or whatever. There was this, because we were using methods that were really designed for those situations. And we wanted to understand, I think economists wanted to be more scientific. I think that was a kind of feeling that we had. And then there was this paper by Lalonde in the 80s. I think it was 81 actually, but I'm not
I love all these historical stats paper references.
Not totally sure. So basically, he actually managed to get his hands on some actual experimental data in economics.
Okay.
And then he said, what if we'd applied all these methods that people have been using, claiming that they're getting causal or as good as experimental evidence? And what answers would they give us, and how good would they be?
Right.
And basically, so things like differences in differences, instrumental variables, whatever. And basically, they all did terribly badly.
Right.
So I think that kind of kickstarted people thinking like, oh, if we want to know like what the actual causal impact of changing this one thing is, we have no alternative but to go in there and randomly change it.
Yeah. Okay.
So I think that led people to, to wanting to do that, because there was this knowledge of how big the gap could be between what you think of as a sensible approximation to that experiment and the actual experiment itself. And I think we have to expect that in a young discipline. Like economics is a relatively young academic discipline. Relative to like physics or biology or whatever.
Yeah, it's always annoying to me when like people in the media are like, well, how come economists didn't predict blah?
Yeah.
I'm like, bro, we've been around like 3 seconds.
Yeah, exactly. Like, it's like 250 years or something that this has been a formal study at best, at most. Like, So it's like, you can't, what were the physicists doing 250 years into physics? Like, I think the rock likes to be on the ground. Like, that's like...
gravity!
Yeah, exactly. Oh my God. No, exactly. So, like, we're definitely pre that. And so I think what was exciting was like, but if we do an experiment, then we're kind of like biologists or doctors.
Yeah.
And we can actually do, like, there seems to be possible to do these randomized experiments. And you can actually see the impact of, like, just like in a drug trial, the notion is like, well, I could randomly give 50 people, a scholarship to go to primary school in Ghana, just like I could randomly give them aspirin for their headache, and I could, like, see what happens.
Yeah.
And so I think that was very exciting to people because it was just like, we were never close to anything like that before. Like, it just was so cool to think you could actually get a fact like that, right? In that sense of like, I actually could find out. And that's so exciting. But I think, economics and social science in general, we always have this, like, searching for our keys in the lamplight problem where like you're like, it doesn't matter where you dropped your keys in the dark, you're searching where the light is. Do you know this
No, I don't,
story?
but I like it.
So it's like a drunk man stumbling home and you come across this guy and he's like peering into this like pool of street light. And you come up to him and you say, what are you doing? He says, I'm looking for my keys. And you say, well, where did you drop them? And he says, I dropped them back down the street. And you say, well, why aren't you looking there? And he said, well, this is where the light is. So I'm looking here because this is where the light is. So I think that's what happened to some extent. That's what causal, at this point, there's like, we can answer a limited range of questions really, really well using this methodology. And that's really exciting because, like, there used to be no light at all. So now we have like this one street light that's over here. And that's really valuable. Like, I think it's like, it's a problem that people want to denigrate that because it is really exciting. Like, it just, nothing beats knowing, like, there is something here, like, cool. On the other hand, what you should not do is get confused about what you've learned. Right? Like, you're asking a very limited question in a very specific context. If you want to extrapolate that knowledge to something broader, you just won't be able, like, you're just going to need a different approach. So if you're trying to understand something like, why is it, for example, that the birth rate in sub-Saharan Africa is still extremely high? It's fallen off in other places that have had, comparable economic patterns. Why is the birth rate in sub-Saharan Africa still very high? That's not a question that you can answer in a randomized trial. Right, so I actually have an ex-PhD student, Celine Zitfeld, who's now incoming faculty at the Stockholm School of Economics.
Cool.
And, she wanted to answer this question. And I think, there's a lot of pressure now on young economists not to answer questions like that because you can't study them with an instrument or with a randomized trial, which would really be the best. And yet, at the same time, we need to do our best to understand why it is that there's this high birth rate in sub-Saharan Africa. And you're going to need a different set of methods. I was pointing her more towards this sort of methodology that they have in political science, which is more Bayesian, which is more based on these, like, models of what the world could be, or, like, different kind of theories of what could be happening, and then going in and really checking the patterns in the data in the world. If this theory is what's happening, we should see this correlation between these two variables. Let's go and check that. If it's this other theory, we should see this correlation between these other two variables. Let's go and check that.
Once you've ruled out the impossible, whatever remains, however improbable, must be true.
That kind of like investigative data sleuthing is, an incredible asset. It's, and yet we don't really teach it formally. And it's not really valued at the moment, but I think it will come back because there's just a limit to how much you can learn in randomized trials.
Yeah, well, let's talk about that a lot. So that sounds, what you just described to me sounds a lot like sort of preparing falsification. So you are adjudicating between competing hypotheses. You've like sat in the armchair, you've had a good think about it. Like, well, it could be this, could be this, could be this. So I'm going to set up some sort of, not an experiment. An experiment would be ideal, but as you said, it's just not feasible in some cases. But I'm going to set up tests. That will help me to adjudicate between these hypotheses, and then if the data really points overwhelmingly in one direction, I can't be certain that that confirms my theory, but I can falsify these other theories. I can be like, well, they don't have any support, so I can probably ditch those. Maybe they'll come back later in some other format. But I think that certainly one of my grievances with economics at the moment, and it's interesting that you mentioned Pulsar, because I feel like they're very much following economics down this causal inference pathway, is that approach to knowledge building has sort of been lost. So I as an anecdote, I remember Angus Deacon's always banging on about this because he's not a fan of randomised control trials, or at least he thinks they're a bit over-egged. And he was making the point that you can learn a lot in a scientific sense from just crosstabs, like just sort of getting summary statistics and being like, well, it's not this because that doesn't make any sense. And someone put a tweet up on this saying, oh, well, forgive me, but I prefer my knowledge to be driven by science. And what they meant was randomized control trials. And I was like, oh, God.
Yeah.
And, they had a PhD from a very, very top school. And I was like, this feels to me like a failure of education about what science is.
I think that's true. I think there's like a, it is just a failure of education, or like an over-identification with like medicine, for example. But even medicine like struggles to deal with the fact that like the human body and also human societies are like complicated interlocking systems.
Yeah, epidemiology.
Exactly. Like it's very complicated. Like you're not going to be able to get the whole puzzle from things that you could get from an experiment. Like, so I'm not as pessimistic as Deaton. Like I obviously share some of his concerns because a lot of my work is about like quantifying the limitations of randomized trials. But like actually when we go in and look at it, like a lot of these results are quite generalizable. That's just one question, right? That's not the same question as like, okay, well, why, did the credit access have this or that effect in certain regions? That's a different question, and you would need a bigger machinery and a different type of modeling kind of approach. But like we're going to have to, I think, develop a new kind of approach to inference for social science, because nothing on the shelf at the moment is going to cut it. Like we need a way to stitch together like these really well identified causal effects from experiments with crosstabs from the actual world that we live in. Because like at the end of the day, what you're about to do is go and make a policy at a country level probably. And that occurs in a context that you need to understand. And so you have to bring those two things together. We don't have a methodology for doing that. There's these micro-founded macro people, and they're working towards that. But a lot of what they do is calibration, which is not estimation, right? So that's calibration is like, I took a number from somewhere and I stuck it into the model. They don't even put the confidence interval in. So why don't they do that? Because it's very difficult. It's very difficult to do. We don't have a standard methodology to do it. I personally think that a Bayesian methodology is a very natural and promising way to do it. But like, it would take me years to develop a methodology like that. And I'm working on like other things.
And meanwhile, macro is changing so fast, right? Like decade to decade, the macro economy looks completely different to the way it looked a decade earlier.
No, exactly. I mean, it is like, I think it's good to have these sorts of discussions. But like, like we're just so far from where we could be. Like we have to take that, I think, approach of saying, we really need to try a bunch of new stuff. Like, it's very likely that what we're doing now is nowhere near the best that we could do. And so we need to be like willing to get very creative about like how we could go forward.
All right, well, let's maybe then speculate wildly about how we might stitch the social sciences together. I think that's a really interesting topic. So I spend a lot of time reading psychology, and it's been interesting watching. They have an excellent journal that I really think economics should try to copy, called Perspectives on Psychological Science, which includes a lot of papers just written by psychologists on the process of psychological science, but also invites a lot of commentary from outside the discipline on it. And I just really feel like economics could use a lot of commentary from outside the discipline.
I agree.
And it's quite a prestigious journal, so they can be afforded to be quite selective. So you don't just get like people calling out the neoliberalism of economics or whatever trash is currently being talked about it. So yeah, in Perspectives, they recently just had I think it was the most recent issue on the theory crisis in psychology.
Oh yeah, cool.
So talking about how a lot of theory is really just the restatement of empirical regularities as opposed to actual theory. And then in other recent issues, they've had kind of the opposite, like sort of problems with kind of not having good enough statistical models. There's a lot of interesting work coming out about the need for psychologists to get more comfortable with the kind of quasi-experimental work that economists do, because I think an interesting kind of contrast to economics is that psychology has proceeded mostly in the laboratory, I mean, with human subjects, but still everything in experimental conditions. And now, particularly in social science, psychology, they're realizing that, as you say, all these things are embedded in complex social systems, and so you can't study it in the lab. You have to take it to real world data, but then you run into all the problems that economics is really familiar with.
But what's really interesting is like this problem is not even limited to social science. So like if you think about studying bacteria in a petri dish, like bacteria, like we don't live in a petri dish. So the bacteria that we encounter is actually quite different. The distribution of the types of bacteria that we encounter in the world is substantially different to the bacteria that you can grow in a petri dish. And there are actually like biologists working on this and developing like soil-based mediums for studying bacteria. And they've already discovered just like huge amounts of additional like new types of bacteria that we haven't been studying, and like this has implications for like antibiotic resistance, stuff like that. So this is a problem that affects everybody. Like you're able to study things in a way that and then you learn more things about the stuff that but like the way that you're studying things necessarily includes or excludes certain realities, and you have to be very careful not to confuse like what you're studying with the entire reality around you. And I think also like I think it's really important to be able to establish like what we would think of as quote unquote reduced form facts about the world. So just things about like what is the correlation between variables in the world. Like, those are super important. But you need to, I think, always be mindful of the fact that like, even just conceiving of variables and measuring them proceeds on the basis of a theory about what the things are. Like defining stuff embeds an understanding of the stuff. It's not like you just get definitions from nowhere. Like definitions of variables that we're studying are created by us. And like those definitions embed theories about how the world works. And like when we lose sight of that, we start to get stupid about like what we actually learn. So like this comes up all the time in economics, and you would think that it couldn't, right? So you would think that like, profit, like you'd think, profit is just what it is. Actually, profit is like defined in a certain way. There's lots of different ways to define it, and this makes huge differences in how you understand what's actually happening. Moreover, if you want to like understand or study it, like there's all sorts of like weird things that seem like weird statistical problems when you're dealing with profit data that are actually like extremely obvious indicators of an underlying economic reality if you remember to like switch your economics brain on.
Use your head.
So like when I was studying the microcredit like profit data, I was trying to apply like a method from like a very general method that's based on quantile regression to these outcomes, and like just every time I would try to run this model, the computer would just give me an error, right? So I was like, I don't really understand what's going on. And like, I must have a bug, looking through it. Eventually I did what I had always been told to do by my stats professors, never by my economist professors or econometrician professors. My stats professors, in particular Joe Blitzstein, who teaches Stat 211 at Harvard, who's incredible. He always said, like, the first thing you should do is make a histogram of the data, like graph the data.
So I learned econometrics first from Trevor Broich of the Broich-Pagan test.
Oh, yes.
And he also, like, very first tutorial was like, you should always start by scatter plotting your data, and if the relationship is not there, it's not there. He was always like, visualize.
Right, so like, if you make a histogram of this profit data, you can see why the quantile regression doesn't work, because there's a big spike of people at zero. And, you're immediately taught to think like, that's some kind of problem with the data. But actually, if you think about how the data was sampled and how profit is defined, like we're sampling people in villages. Actually, not all these people operate businesses. So if they don't operate a business, they make zero profit by definition. So there's like lots of people there that are not operating businesses, and there's this big spike of people. So yeah, that means formally you can't use that stats method, but that is telling you something about the economy. And actually you could like build a model, a stats model that would like help you learn about like, oh, people moving in and out of the spike of zero. You know, if I change something, does that spike get bigger or smaller? That's a separate question to, is there more on the positive, is there more on the negative side of the people who are not in the spike?
Yeah, right.
So, but it's, you know, knowing about that, you have to know a little bit about how like people in rural developing village economies work, how they live. You have to, like, someone at some point has to go there and talk to them and see them and you know, if you don't have that knowledge, you can't do the stats. Like, you won't understand why the formal stats is failing.
Okay.
So I think it's like, it's all tied together.
So we've raised so many things that we need to talk about here. So you just mentioned like we need to go there and talk to them. So that sounds kind of like, you know, a bit qualitative. And I think that there is a kind of groundswell or somewhat of an upwelling of interest, I think, in high-level economics, particularly in development economics, to do more kind of mixed methods stuff involving qualitative research. And before, when you were talking about these soil-based bacterial models, that really reminded me a lot of complex systems theory, which is one of the spaces where randomized control trials just really break down, but also where probability is like crazy hard. And I remember a really good talk by someone at Brookings when I was there on using complex systems theory and agent-based models to look at the kind of social determinants of obesity. And they build a model where people will have very simple behaviors around eating and consumption, and then they created a geographic space in the model for where food shops were and food deserts and this kind of thing. And then you just like change the parameters and run simulations and kind of look at what's going on. And that allows you to get some sense for what's happening and to test your theories, but you're not using a randomized space. So I guess one way to try to put this back to you as a question. So in terms of like how we should think about what is good research in economics. So like at the moment, I think there's a strong emphasis on good research is randomized control trials, or at least something that approximates that. And also ideally answers a pretty interesting question. But I think we put a very strong emphasis on identification at the moment. So if we think that that's a bit too heavily weighted in one direction, and we wanted to promote a diversity of good research, what do you think are some of the markers of good research in terms of stats, in terms of methodology? Yeah, it's a good question.
So it's very, I think that good research starts with like a question that you can actually care about.
Who cares?
Yeah.
Like, I think that is like a bar that a lot of research projects don't clear. Like, no, like, you know, there's just, and you have to start with like, why would you care about this thing? Like, why do you want, and like, you know, I think it's almost it's almost like identical to just say like good research is grounded in like an understanding of the world that you're in, or like a curiosity, let's say, not understanding, a curiosity about the world you're actually in, not a curiosity about the literature that you're in. Like,
well said.
Like, that is, I think, you know, you have to be looking out the window and saying like, why is it like that? And like, we're so far in social science from understanding why what's outside the window is like that. Like, I'll leave it to the psychologist to tell me why what's inside the window of my house is like that. But like, you know, it's my job to tell you what's outside the window. Why is it like that? You know, just anything, just like, you know, based on that curiosity, I think is the first thing. And then I think you want to say, you know, once I've got a question that I could actually care about, what is a way of getting traction on this question that I could actually believe? So I think like there's too much reliance on like, oh, well, in Green's textbook, he says that multivariate regression has these properties, so I'll have to use, you know, multivariate regression, or like, you know, the law of large numbers says this, the central limit theorem says that, therefore, you know, and it's like, okay, but these are all like theorems about behavior variables that are proven in like mathematical structures. They're not, these are not like, it's very unclear what resemblance those things bear to the actual world that you're in most of the time. So instead of thinking about what methodology is like approved by the people in your profession, you need to think like, what methodology would allow me to like actually learn something about this question that I care about? Like, you know, what information would I need to know? What kind of problems would I be confronting if I was trying to do this inference? Like, and I think those are kind of the major ingredients. Like when I'm advising students or when I'm thinking about my own work or reviewing papers or whatever, I'm like, is this a question I could actually care about? Yeah. And is this, like, do I actually believe that this method is delivering me any kind of new information about this question that's relevant to this question? Yeah. I think that's kind of what I think of as good research. And then once you've done that, not to like oversell what you found or try to pull kind of extrapolate beyond what you could actually get. That is, we do have like a bit of an issue with that, I think, in economics, because we've been getting away with it.
Holy Heidelberg, what'd you do that for?
I'm afraid we've been drugged, Robin.
I guess you could never trust a woman.
You made a hasty generalization, Robin. It's a bad habit to get into.
So that's what I think of as good research. And a lot of that good research, like, you know, is, correlational, or just understanding, like, what is the value of this statistic in the, you know, like, if you think about, like, a lot of my work is just, like, what is the variation in these parameters? Like, how much do they vary? Yeah. That's not, like, a quote-unquote, like, causal question. It's not a causal question. It's just an empirical, like, what is the variation that we see? But it's very important. You can't really interpret the causal effects or extrapolate them in any way until you know that variation. And similarly, like, until you cross-tab the actual, you know, variables in the economy, you don't know how to make sense of the partial effect that you measured in your experiment. Yeah. So I think it kind of goes together that way.
Yeah, no, I'm very sympathetic to everything you just said. And I particularly like this idea that, like, if you start with questions that matter, then in a sense, there's a rebalancing, and I don't think you want to overweight this, but a balancing towards, like, well, I may have a relatively crude model, or I may have a relatively crude method or a measurement instrument or whatever it might be, but at least I'm asking a question that matters. Yeah. And we're going to make progress on questions that matter, and that's going to be incremental because those questions are really hard. Yeah. But at least they're important. Yeah. And I do think that ultimately science is pretty well balanced. But sometimes I do worry that we put too much effort on really good answers to really kind of quite boring questions. And we relegate ultimately quite big steps forward on hard questions to modest journals because they're not sort of bulletproof answers. So maybe to finish off, because I think we've been talking a while, but it's been a riveting conversation. Do you think that there's anything institutionally within the way research is structured that could be reformed to improve these kind of things without getting into like open science and that sort of stuff? But just like anything like on that front.
Yeah, so I actually have not spent a lot of time thinking about this, just because it's like I don't have at this point the power to do any of those reforms. Like, you know, the only lever that I have, because I think that people, you know, should do more aggregation and evidence synthesis work, which is the kind of work that I do, because that's what I think we need more of. Like, my only lever to get people to do that is to like try to convince people that it's interesting. So I think in terms of like getting people to focus on big, important questions rather than incremental, you know, small questions that are not that interesting. I don't know, like, I guess the only thing that I have thought of along these lines, and I think editors of journals are starting to think about this too, is that like, it means that as a referee or as an editor, you have to start like reweighting what you're what you think of as like worthy of publication.
Yeah.
And like I'm not like I certainly think that there need to be standards. It's not that any old opinion about a hard question is worth publishing.
Yeah, absolutely not.
Absolutely not. Like, that's the point of peer review. But it's like, you don't, I think you want to create a kind of culture where there's value explicitly placed on like trying to take kind of big swings. I think economics is actually better than many other disciplines. Because we prioritize relatively few big papers. And that leads you a little bit more to say, I'm going to take a big swing at a big question. And you don't need to publish a lot. Yeah. Like, I've always been embarrassed when academics in other fields ask me how many papers I write in a year. It's like 1 if I'm lucky. Yeah. 2 is like a monster. Yeah. Like, then I need a holiday, like, big time. And I think that is good, and I think that's a good thing about economics. Like, I don't know, broadly speaking, in terms of incentives, the thing that I've bumped up against is like research grants and funders are quite conservative. They want to be able to, justify what they're spending money on. They kind of want to see the output when you pitch the grant. Exactly. Yeah, and so that makes it hard to take a big swing. So if I could like put like a prayer out into the universe type of thing, I would say I would like it if there would be more research funding for bigger, more complex, thorny questions. And I think there have been some, like we saw like Berkeley's initiative for transparency in the social sciences. Yale had their Y-Rise initiative. But so far, there hasn't been a sustained source of funding year on year available for researchers that want to do, methodological innovations, tackling questions that, like there's lots of funding for randomized trials. That's not to say, like, there's lots of competition for that funding as well, but like every year there's like funding rounds for randomized trials. There is not funding rounds every year for like evidence synthesis. Yeah. Sure. Like we are watching it and it's like once every 3 or 4 years, somebody somewhere, like Settle, which is a different imprint, did one a couple of years ago, and we were lucky enough to get one grant from there. But otherwise, you're really in this wasteland where you're waiting for like Bits to do one round, Settle to do a round. Like there's no sustained research funding for it. Yeah, right. That makes it challenging. And so, I wish that was different because that I think would change a lot of things. But, we're going to control that. Control what we do. That's great. So one idea I have that I'd love to run by you quickly is because you mentioned as well, like economics is really focused on papers. Yeah. And I do sometimes worry that actually books would allow for some of these messier questions to be tackled in a systematic way where each of your chapters is maybe a little bit flimsy. Like you did a big qualitative study, you did your quantitative study, you did a synthesis, and everything's kind of pointing in this way, and you bring it together and you're like, here's the book. Do you think that that's feasible, or are books always going to be a bit choppy? So I don't know, because like we're so far from that in economics, but I will say that I instinctively would push back against that because I think that papers in economics are too long. So I don't want to give people more length. I think, and I would count my own papers also as being too long. When you write long papers, like you're kind of wasting people's time. It's unfortunate. So I think, it is hard to distill things down into very, very synthesized type. Especially with our refereeing culture. Exactly. Exactly. And the referees are like constantly telling you to add stuff. And then in the second round, they think of more stuff that they didn't think of in the first round that they want you to add. And there's like no discipline at all. So I think that is pretty bad. But so no, I wouldn't. I don't think moving to books, although again, let me bookend that with the caveat that we're so far from that that I feel it's hard to evaluate that. So if moving to books meant longer, then no, I would not be in favor of that. But I think it would be nice if we had somewhat more diversity of what was valued at the very top of the kind of publishing hierarchy. Like right now, like I routinely get asked, like, would you write us like a paper explaining about partial pooling methods?
Mm-hmm.
So partial pooling methods are like very related to what I've been doing. When you're not sure whether you should be combining evidence across settings because maybe it's too different and you're wrong that it belongs together. But on the other hand, it might belong together. And if it did, you could really learn a lot. So you don't want to pool it all together, but you don't want to leave it all separate. So there's a suite of methods called partial pooling. Exactly. Right. So there's like models that allow you to figure out from the data, obviously filtered through a structure, where you draw that line.
Cool. So
very promising, like it's related. I mean, it's been there for ages. This is what hierarchical models do in Bayesian inference, but it's also part of machine learning, certain machine learning methods. And people are thinking about this a lot. This is what's called shrinkage in statistical methods. So I routinely get asked, like, would you write like a primer or like how to do that, or like because I've taken the time to kind of sit this, like to digest that for myself, and it's like I would love to do that. I would love to spend my time writing a primer like that. There is no way I could publish something like that in a journal that would put me anywhere towards getting tenure. I might as well write like a sequel to Cat Person or whatever. Like it's just not. So I think that would be nice if we had like more diversity. If it's like primers on like new methodologies was seen as like a contribution, because it actually would be.
Yeah, the same way that like if you write R packages and stuff, everyone's using it.
Everyone's using it. You're advancing science, but it like you might as well have like gone and played golf for all the benefit it would give you for tenure, and that is fucked up. Yeah. So there we go. Now we got something to rail against.
Yeah. Okay. Wonderful. All right. Well, this has been a really great conversation, Rachel. Thanks so much for coming on epidemiology. I hope you had a good time.
Yeah, I did. Thanks so much for having me.
Epidemiology.